Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, I am Charity Majors, co-founder and CTO of Honeycomb and co-author of the upcoming Observability engineering book. And I am here with my co-authors, Liz and George.
Hi, I'm Liz Fong-Jones. I'm a principal developer advocate at Honeycomb, and I got roped into this book project a couple of years ago, which is exciting. And we're really glad to have George on board as well.
Hi, I'm George Miranda. I also have been at Honeycomb. When I joined Honeycomb, the book was somewhat in its infancy, and I was super interested, so I just jumped right in. And together, we've all been cranking on this for a while and getting it done. So I'm super excited to be here to talk about this book today.
I feel like when George joined, Liz and I were both like, hey, we're half done with this book. Do you remember that?
To be young and naive.
Exactly. Yeah, this book has
It was my first rodeo with a book, but it was not Charity's first rodeo with a book.
I've been doing the book for a little while, and I thought we were half done. Anyway, Liz came on board first, I think, and drew up a whole new chapter outline, and we started writing. But I don't really feel like the train got its wheels on, and that's a bit of a metaphor, until George started. And he just brought so much structure to the process and so much, like I would spew out a couple of pages of just like notes off the top of my head, and he would turn out these beautiful, nicely crafted entire chapters. And I feel like that was when we finally got an actual rhythm to it. Absolutely.
And I think the three of us have been a really good combination to, I guess, you know what? This is not my first O'Reilly book, but I've written much smaller length O'Reilly books. And I think working with you and with Liz has just been super informative for me joining Honeycomb. It was a way to.
You were new, and
I was
you had
brand new.
A newbie.
Exactly, a brand new bee, and this was a way for me to really wrap my mind around the nuance and the difference, and having the two of you to lean on in terms of the insights and just sort of the different areas of focus that you both brought to the table. I think one really let me absorb that, working with both of your writings, really internalize it. And I think it took me a couple of months to really wrap my own brain around it. But then as we kept going, there were parts of the book that I was then able to own and run with. And so I can only hope that as folks read this book, that they also are able to glean so many of the insights that just made things click, that made the practice of observability like really easy to understand and follow, and to really understand why it is such a paradigm shift. And I hope that's what people get out of it. I think we've done hopefully a pretty good job of it when I look back at it. Maybe.
I hope so too. And it's been nice having the reader feedback all along is the main thing that I have, because that is, but also things have been changing along the way pretty quickly. Like it wouldn't have taken us this long to write it if observability as we know it today had existed in its present form 3 years ago. Right, Liz?
Yeah, definitely. One of the key things that I was lamenting to George almost was that when we originally sat down to write about OpenTelemetry, we were imagining that it was going to be this giant effort to explain to people how they should instrument their code. And then it turns out that other people have written really excellent documentation, so we can almost provide a pointer to existing documentation rather than having to explain it all ourselves. And also the code examples that we use now are 1.0. There's no longer oops, this is already out of date, from the moment the ink is dry.
Yeah, for sure. Well, maybe I'll talk just briefly about, the origin story for Honeycomb, which is kind of the origin story for observability. And I know Liz has her own spin on it coming from Google, but like when we started Honeycomb back in 2016, like observability wasn't in the air. Like I think Twitter had used observability engineering for a name of its team once, but like it wasn't a thing. And when Christine and I started Honeycomb, it was after this experience at Parse that we had had. Parse was this mobile backend as a service that was acquired by Facebook. I wish. Acquired by Facebook and shut down. And like the experience that we had was, Parse was doing a lot of stuff that was, before its time. We were doing microservices before there were microservices. We were doing like these multi-tenant platforms, when all we had to understand it were metrics, aggregates and logs. And Parse was going down like every day. Like it was professionally humiliating to me just how often like the site was going down. And we tried everything to, all of the current best practices, and nothing really worked until we got acquired by Facebook and we started using this tool called Scuba. And we piped some data sets from Parse into the Scuba data set. And the time that it took us to identify what was the problem, it was a different problem every day. A different app would hit the iTunes top 10, and it just like, there was no predictability to what was causing it on a day-to-day basis. And the time it took us to identify and solve these problems after we got data sets into Scuba dropped like a rock, like from, open-ended hours, days, we might never figure it out. It might just recover on its own, to like, not even minutes, to like seconds, to like the point where it wasn't even an engineering problem anymore. It was a support problem. And this had a huge impact on me because, we got a hold of our reliability issues, and, we moved on with our lives, and it wasn't a thing. And then when I was leaving Facebook, I suddenly went, oh shit, I don't know how to engineer anymore without the stuff that we've built on top of this. Like, it's like the idea of going back to the dark ages. I was reading the other day about how when pilots went from, only having visual stuff to having instrument ratings, being able to fly with their instruments. And it was like the idea of going back to only having VFR again, right? To only being able to see, and so like, that's why we started Honeycomb. And it was like 6 months into Honeycomb when the hardest job in the world is product marketing, I swear to you, because, we were trying to figure out how to describe what we're doing, and we knew it wasn't monitoring, but what was it? And it was like in July, 6 months after we started the company, that I Googled the term observability and I read the definition, right? It's all about how well can you understand what's going on inside the system just by asking questions from outside the system. And I just had like light bulbs just going off, like, oh my God, this is exactly what we're trying to build, right? And so we started trying to define observability for systems, and the definition caught on really quickly, a little too quickly. But then when Liz joined, a couple of years later, like you had a very different angle that you were coming at this from.
Yeah. So I lived in the future, right? Like I worked at Google, and we had all of this super advanced technology, including tracing, including metrics, and kind of we'd done work to pioneer stitching these two things together in a way that was available to site reliability engineers at Google. But one of the challenges was that as much as Google lives in the future, it also reinvents everything because it's inventing the future. And therefore, there's this huge gulf between, towards the end of my time at Google, I was working with Google Cloud customers, and I was like, how do we help bridge this divide between people who are using Google Cloud versus people who are using the shiny and cool and interesting Google stuff? And of course, we didn't use the word observability for this. It was, what is your monitoring situation? What is your position with service level objectives, right? Like, but what I realized was that the most effective way for me to level up the industry was going to be helping everyone, not just the people at Google maturity, get good at observability.
I love that phrasing of like you lived in the future, because that's exactly the experience that we had at Facebook, right? Like living in the future tool wise, but bridging that by, living in the past or the present in terms of like the rest of our stack, and like just wanting to like bridge that gap is exactly where this came from. You talked about SLOs, which, when you started at Honeycomb, that was the first thing. I think it was on day one. You're like, Charity, it's time to build an SLO product. And I was like, it took me a little while to understand the vision, but I completely understand it now.
Yeah. So one of the key things I'd seen people struggle with was that at Google, we really, really encourage people to stop alerting on stupid things, to stop alerting on the CPU is too high or the disk consumption is too high. And instead, we advocated that people set goals for user experience, or service level objectives, and to alert only on those, to alert only if, over a 30-day window, it looks like you're going to stop having 99.9% of your requests succeed. If it looks like 99.8% of your requests are going to succeed instead, then you need to intervene and stop that. But the problem that we saw with adoption of that was that people were like, but you can't take my safety blanket away from me. How will I be able to debug things if I don't understand which individual servers are having problems? Right? They were stuck in this mode of the only way I can debug things is starting from the very bottom of the stack and looking up, even if things are randomly flopping at the bottom of the stack all the time.
The formulation that you and I kind of came up with was, that you need observability to understand from the bottom up what's happening, and you need SLOs to understand from the top down whether or not you should care.
Right. And the observability is that connective tissue to help you systematically debug from the top down to figure out where in the stack is this problem happening, rather than having everything in the stack blaring at you at the same time.
Because it's a super core principle of observability that everything matters right down to the raw rows, right? Like the way that we can take, your data and with bubble up, you can just like draw a bubble and go, boom, that's where it is only by capturing all that really rich context.
Capturing the really rich context, but crucially, you can have all the data in the world, but if you can't actually analyze it and slice and dice it in real time, you don't actually have observability, right? Like, I think that's the key thing. Like, people have been collecting logs and having them sit on a shelf for ages.
Yeah. George also has a background in operations, which is part of why I think we all gelled so well here.
Which is what I was going to bring up, right? Which is, while you two had both been living in the future, I was definitely, a product of like the past or the present. And Charity, I love the VFR example that you were making, right? Because really that's what we're talking about. It is that leap from I see and, can viscerally connect with what is happening because I'm so intimately familiar with the system, which is how I was used to thinking about production and like having to gain that knowledge over time and having to really, gain that experience and troubleshoot through intuition, switching to a mode where you can use your instruments and you can rely on it. And in fact, I don't know if you know this, that part of, your flight test at some point when flying with instruments is sort of Luke Skywalker style. You put on a face shield and you can't actually see out the window, and you're supposed to fly just with your instruments, right? And
nice.
Observability kind of gets you to do the same thing, right? Which is realizing that now it is technologically possible to gather and analyze this much data, right? Like an unfathomable amount of data that just simply was not possible, even as far back as, a decade ago. And as an industry, there are so many things that we have normalized when it comes to intuitive troubleshooting, right?
Yeah, we made so many compromises, right? Like we said, you have to use metrics because metrics are the only way that you can handle that much data. And that was true 10, 20 years ago. That is not true today.
Right. And so that I think making that mental leap, right, is something that I had to make coming into Honeycomb. And I think from part of the reason that we all gelled so well is I think that's the perspective that I brought to the table with the book, right? So, not having quite made that transition, how do we lay the trail successfully to figure out how to take a methodical set of steps to stepping away from troubleshooting by intuition, right? So Liz, when you say like, don't take away my security blanket, that's kind of what I think about, right? Like I am so used to doing things that way. How do we move back to, or I guess forward to a more data-driven hypothesis driven scientific approach to troubleshooting. And like, that's what computer science should be, right? We just aren't used to doing it.
Yeah, right. Like it's scary to people though to move from kind of making leaps of intuition and being like, I know this, right? Like, I can figure out instantly, right? Like with observability, it's taking right, like people have to rewire their brain to think, you know what? I'm not going to necessarily either figure it out instantly or have it take 3 hours. But instead, if I follow this methodical set of troubleshooting steps empowered by my tooling, I will be able to solve every problem in 5 or 10 minutes.
This is why, people often ask us, well, do I need observability if I have a monolith? And it's like, not as much, because when you have a monolith, you can pretty much tell at a glance from your dashboards whether it's the web, the database, or the app tier, right? But you never don't need your instrumentation and telemetry. It's never not better to have it, right? And it's really that panicky feeling that people get when they don't know what's going on. It really, most of our customers have come from people who are on the edge of that, who have felt that, who have seen what happens when their intuition can't keep up. And that's when they're willing to invest and learn how to do things a slightly different way. And then it's never as bad as they thought it would be. But yeah, and don't get me wrong. My niche as an engineer is being the first infrastructure engineer and being the person who built the thing, who knows the thing better than anyone else. I love that godly feeling that I get from looking at a dashboard, stroking my beard and going, it's Redis. I know it doesn't say it anywhere, but I just know that it's Redis and I feel like a god and you can't take that away from me.
Your big giant bushy gray beard, Shirley.
Yes, exactly. I stroke it. It's there. I miss that feeling too. But then also when I went on my honeymoon to Hawaii, I was getting called at 3 a.m. and 4 a.m. because parse was down in MongoDB. Nobody could figure it out. And so, they were calling me. It doesn't scale. It doesn't scale. And our architecture, our systems are getting to the point of complexity where it doesn't matter how bushy your gray beard is, there are still going to be more problems that your intuition hasn't encountered before and cannot debug than there will be ones that you're familiar with.
And we accept that as normal, right? And we accept it as sort of these, there's a set of unknowable things that happen in production, right? Production is unpredictable and it's chaotic. And so nobody wants to touch it or break it, or you approach super carefully.
Or even worse, right? We're talking about this thing about, right? There's no way we could possibly understand that. We'd have to push new code, right? And it turns out that the key difference between monitoring and observability is moving from, we have to push new code to understand things to actually we've already added the right instrumentation to debug things that we never anticipated would be a problem when we wrote the instrumentation.
And this is where I know that cost models are not the sexiest thing to talk about with engineers, but the cost model of metrics is it scales linearly with every question that you want to be able to ask. Right? Every custom metric that you capture is another increment of cost, right? Versus the model with observability, where you're already capturing these arbitrarily wide structured data blobs, one per request per service, and just throwing another key value pair or 2 or 3 or 10 or 15 onto the event is free, right? And so you're incentivized to capture everything that might be useful someday, and you're not getting priced out of it. I mean, it's literally free if you're using Honeycomb to add more events because we price per event. It's basically free no matter what you're doing because, adding a couple more bytes onto, a packet that's already getting shipped is not that expensive. It's not literally free, but it's approximately free for most people. Which means that you don't have to sit there and cull out, ooh, we haven't used this in a while. Ooh, I'm going to reap this because I want to save money and costs.
It hurts my heart every single time I see a conference talk about how to limit cardinality or how to or how to pre-aggregate things in order to save money on your metrics.
Let's talk about cardinality for a second for the kids at home. George, you want to define it for us?
Yeah, sure. So cardinality is basically the uniqueness for a particular table. For a particular value, right? And so, something with low cardinality could be something like gender, for example, right? Like it's more than just binary, but there are, a handful of like different ways to identify perhaps, right?
Liz might fight you on this one, but
yeah,
but I get what you're saying.
But right, sorry, I couldn't come up with a better example on the fly. But something like customer ID or transaction ID, right, is very high cardinality, incredibly unique. And so the challenge with high cardinality comes in.
Well, the challenge is with metrics, they're just not built for it. There's modern metric systems have gotten to a point where they can afford a couple, but you're going to blow out the key space really. You'll blow it out really rapidly, and it's going to cost a lot of money. And it all comes down to how bits are being laid down on disk, and it's just not efficiently built.
Which is one of the chapters that we have in the book, right? Like I think this is why I'm really excited to kind of methodically lay it out in writing, like systematically for the people who learn best through writing. Because Charity and I and George have been talking about this for ages, but like, at some point you have to see that kind of rhetorical argument. You have to see that diagram that shows that you are wasting a lot of bytes on disk. You are wasting a lot of kind of room in your indexes if every single index is unique, right? Like that's the problem with high cardinality, is that if a value or combination of values only appears once, you're paying all of this overhead to store like the name of the index. And then there's a singular value at a single point in time, and that never gets reused again, right? Like that's why people in the metrics world have been like, you have to reduce cardinality. And we say, no, you don't have to reduce cardinality. You have to embrace cardinality. But I think there is an interesting thing here, which is Charity talked about the fact that observability makes it so that the cost does not scale in the number of questions that you have to answer. One of the main pieces of pushback that I always saw against wide events and observability was this idea of, oh my goodness, like it's going to scale linearly in the amount of traffic my service receives. And I think that's where another innovation really, really comes into play, which we have a chapter in our book about sampling, about how you can have it not scale fully linearly with the size of your service.
Which is such a dirty word in production engineering, because, I blame the logging companies who've been making bank for decades just saying, save every log message, don't let a single one drop, which is really unfortunate, because if you look at your Nginx log, do you really care about, say, your health check requests at the same amount of, caring as you care about, say, errors to slash payments? No, you absolutely don't. You care about, and health checks, in a modern system can often, account for 20% of your load, like representing, 1 out of 20 of those requests that are all the same, all 200s, all from the same location to the same location, is a huge cost savings. There's a lot that you can do to reduce your cost there without any downgrade in, reliability or your ability to ask complex questions.
So taking a little bit of a step back, I think what I like about the book is that if we start with an outcome, right, that what we're getting at is data-driven debugging, right? And like stepping away from debugging, by intuition and more debugging by hypothesis. What are the things that are necessary in order for that to be true, right? And like you just mentioned, right, being able to analyze all of that telemetry data. Well, first, being able to just gather all that telemetry data, right? And having a data store that can handle that is step one, right? There might be some things that you need to do at scale, like sampling, for example, right? Or like managing telemetry pipelines. But
scale is a lot bigger than people think it is.
Scale is much, much bigger, right? And so what I do like about the book is that we start with what are the fundamental building blocks from a technical perspective? What do you need to do to gather that telemetry and store it? How should you instrument your applications? And then what kind of analysis do you need to do in order to debug in those methods, right? And then we sort of methodically walk through what are ways to automate it, what's the kind of data store that you need, and what functionality do you need so that if your data set is, millions of rows or billions of rows or hundreds of billions of rows, right? How does it need to behave, right? How do you get answers fast? How do you need to construct things in order to get to these outcomes? And so I know we spend a lot of time talking about, like Honeycomb's pricing model, for example, right? But I think what I want to get across is that what we do with the book is, I think there are maybe a handful of times in there when we relate things back specifically to Honeycomb for, product specific examples of this is what like a trace view looks like, for example. This is exactly
what
right.
Implementation of this
but
looks like.
Here are the things that you need if you want to build to this type of outcome, right? And so I'm hoping that's what people really get out of this.
Right. As I think Charity called it showing our work, right? Like how do you, people for a very long time said, you can't possibly do that. That doesn't make any sense. We're like, no, actually we'll show you, right? Like if you want to do it, you can do it.
There are so many definitions of observability proliferating. I'm wondering, can we all come up with our favorite? What's your favorite definition of observability?
Our favorite wrong one or our favorite right one?
That might be more fun. Both.
Okay, well, I think, let's start with my favorite wrong one, which is, you have observability if you have logs, traces, metrics, profiles, every single signal type that your vendor is trying to sell you as a separate add-on. That's my least favorite definition of observability. But my most favorite definition of observability is definitely the one where our customers say, like, I can see and understand my systems for the first time, right? Like, I think that's where the magic is.
I think that's also a little fuzzy though, right? Because because of some of that experience, what people hear with observability is another synonym for visibility, right? Or it's turned into like a synonym for monitoring as well. And there's this, what we frequently talk about is that mean time to WTF, right? Which is that experience that you have when you wire up your applications and you start observing and seeing, like, what are your requests in production actually doing? And suddenly there's this moment of, wait, my code's not supposed to work that way. Wait, it's doing what? Right? And that's when it suddenly clicks that this is it's a fundamentally different way of seeing what your code is really doing. And there's not a great way to explain that unless you actually see it for yourself in a context that you thought you understood one way, and suddenly your mental model shifts and you're like, oh, right. And then you get it. And so, yeah, I don't know, that's what I see. What about you, Charity? What's your favorite definition?
I used to lean a lot on the unknown unknowns type of definition. That, monitor use for your known unknowns, observability for your unknown unknowns. But I think increasingly, I find, and to be clear, the 3 pillars thing bugs the shit out of me. The 3 pillars thing dates from a blog post that Peter Borgen, who's amazing, wrote in 2018, 2 years into when we were trying to define honeycomb as, observability, et cetera. And he came out with this blog post. It's like, there are 3 pillars: metrics, logs, and traces. And immediately every vendor in the world latched on it. We're like, great, we have observability too, because we have a metrics product, a logging product, and a tracing product. And we're just like, no, because it's worse if you have to pay to store it 3 times and then you have to have a human in the middle who's like bouncing back and forth and copy pasting IDs around trying to get it. Like, it's not observability. But that aside, the definition that I've really settled on is it's about high cardinality, high dimensionality, and explorability. Right? There are a lot of BI tools that have had the support for high cardinality and all these things for a very long time. But what they tend to lack is explorability. We talk to teams even to this day who are like, yeah, I can answer any question about my systems that you want. Give me those questions and I'll get back to you in 2 or 3 weeks. And we're just like, what?
Right. It's about speed, right? Like, can you still do this so that it feels like, I think, Charity, you say, be in constant conversation with your code, right? Like, is it a conversation or is it, trying to talk to Voyager 1 where you send a message and it comes back, months later?
I really strongly feel that, we target, like the 95th percentile of our query should, I know this is very honeycomb centric, but, we try to make everything end in less than a second. So that when you're, because when you're debugging, this isn't like dashboards where you're just like sitting there flipping through a bunch of dashboards trying to pattern match from your eyes. So like, well, there's a spike here, so flip. Oh, there's a spike there. They must be related, right? Like, that's not science. That's not really debugging. That's just like pattern matching. But what are you doing? Well, you're starting somewhere. And then you're iterating a lot, right? You might start with something that's like a mile from the end, but you're just like, what about this? And what about this? And what about this? And every time you ask a question, you're checking yourself, and then it might not be that. So you just like roll back and go, okay, I knew I had it like 5 queries ago, right? So you go back and you find it, and then you start going again. But that needs to be iterative, right? It can't break your flow. It can't be the kind of speed where you have to go up and go to the bathroom or get coffee, because that'll break your entire train of thought. It can be a few seconds maybe, but you really need this. What about this? And what about that? And what about that? Because you're on the trail, right? You're debugging something. You've got the suspect and you're in your sights.
Which is, funnily enough, why honeycomb used to be called hound.
Yeah, it is. It's true. It was even bloodhound in the earliest days, although that didn't last more than a couple of months. It's a very aggressive sounding name for your company. Funny story. I love this story. It's a little bit of a detour. We were called Hound.sh for the first 2 years, and then we got served a cease and desist from Hound CI, which, they have to defend their trademarks. No fault there. But, we had like an all-nighter. We're like, what are these names? And, Honeycomb we loved, but it was owned by some friends from Slack. And we reached out and we asked them if they would sell us the domain names, and because it was like one of Stuart's pet projects or something. And they came back and said they would gift it to us and the domain shortener hny.co just for the price of the legal fees to do the switch. So, mad love for Slack. And hilariously enough, Slack became one of our earliest, probably our first real customer at scale. And they actually ended up contributing a couple of chapters to the book that we're working on. George paired a lot with Frank Chen, on their CI/CD platform in particular. Do you want to talk about that a little bit?
Yeah, sure. So I think this goes back to the earlier discussion, right? Slack. When you think scale is usually a lot bigger than most people think. And Slack is definitely scale. And so Frank Chen contributed a chapter around how Slack is using observability in their CI/CD infrastructure and like looking at their pipelines. And one of the things that I found fascinating, I got a chance to spend a lot of time talking to Frank about the particulars of the use case and how they're doing things and really just sort of uncovering some of the whys. And in my operations time, like our pipeline farms were, I don't know, maybe a dozen, 24 servers tops at like the height of just like pushing changes all the time. Slack's footprint just for pipelines is enormously huge. The underpinnings of what might be changing, different versions of libraries, right? Different versions of plugins. It's massive. They are pushing just tens of thousands of changes. And there is so much instability that could be introduced when one small component changes and you would never see it. And so they started applying observability concepts to their pipelines and treating it pretty much as a production application, because for Slack, right, shipping that many changes, it absolutely is a part of production. And so
for a lot of companies, their number one expense is the salaries of their developers. It turns out that is really, really, really important to protect. And this is why the whole developer tooling space is so important, is because people have recognized that you have to invest in your number one asset. That throwing away, hours or days or weeks of developer time is just not a good idea.
I mean, it goes back to, that study that Stripe published that showed that, engineers self-report that they waste 42% of their time on things that, on orienting themselves, trying to reproduce bugs, tech debt, just trying to figure out what's happening, stuff that does not move the business forward, stuff that does not do anything but frustrate the engineers who are working on it. They called this something like the $2 trillion gap or something for developer tools to make engineers' more productive and their lives better.
What I'm hoping is that this book has a little bit of something for everyone. So everything from the introductory underpinnings of, why events are the building block of observability, right? When you're just getting started, to some of the business case for why observability matters, like what it means for your business to move faster, right? Saving those developer salaries, et cetera. And some of the use cases on, the operation at scale side of the spectrum. And so, Liz, we had another contribution from Slack around telemetry management pipelines. You want to say a little bit about that?
Yeah. So
I have one thing to say real quick about CI/CD, which is that most people don't realize that they can instrument their build pipelines as a trace. This has been the number one use case for Honeycomb's free tier, is people just instrumenting their CI/CD pipelines, and suddenly they can see, oh, which tests are slow? Oh, where is that time going? Oh, why is it taking me so long to build and ship and deploy? And that's a great use case. And that was one that it was Intercom actually came up with. That was not a Honeycomb invention. That was a Intercom invention. They started instrumenting their CI/CD pipelines as a trace, and we're just like, mind blown. So cool. Sorry, over to you, Liz. Telemetry.
Yeah. So this was a addition to the book that we were debating and going back and forth on, because this was something that is only applicable at some scales. The idea of how do you kind of route and standardize all of your telemetry that's flowing in, where for a majority of folks, the open telemetry collector will do just fine for them. But we really landed on having Slack as one of the most sophisticated developers of their own observability data pipeline, that we should offer them the opportunity to talk about kind of some of the challenges, why they did it, whether or not you should do it, to kind of make observability feel like it's possible at large scales and not just at kind of medium and small scales, to talk about those real challenges of what happens when, practically everyone in the digital world is using your platform and you're generating all of this data. Like, how do you keep the cost under control, right? Like, we thought that was really important to include in the end.
Switching gears just slightly, how does observability relate to DevOps, SRE, and cloud native?
Yeah, so I think, as I said when we were talking about origin stories, at a certain point you cannot practice SRE without practicing observability. We in fact spelled it out in a lot of our tutorial material on SRE, where we said one of the key responsibilities of SRE is appropriate monitoring and observability. If I were re-recording those videos today, I would use the word observability.
Yeah.
Right. That if
providing that for the entire company, for all of the teams.
Yes, to be a force multiplier, because SREs should not be the only consumers of observability, but SREs should and platform teams should be making sure that observability is baked in. So I think that's kind of one answer to, how does observability relate to SRE and DevOps and all of these things, is that if you do not have observability, like, you are not fulfilling your mission of ensuring that your teams are able to provide reliability.
This is an area where I feel like observability is a step up from monitoring, because monitoring traditionally was concerned with, very low level statistics, right? And you had ops teams sitting there almost like a translation layer between your software engineers who are trying to ship code and the systems. And they're like, aha, so you made this change, and that made, this spike on your IPv4 graphs, and this spike on your memory graphs, and this spike on your CPU. But it wasn't talking to them in the language of endpoints and variables and functions. And so they couldn't really parse it on their own unless they were ops people. And that's a big part of observability that I think we don't really talk about very much, which is just that, it's very, very consciously in the language that software engineers are using every day.
Yeah. So to go to the other kind of intersection with DevOps and SRE, the other thing, when we talked earlier about technical requirements for observability, it turns out that there's technical requirements to implement observability, but there's prerequisites to observability too. That if you cannot ship code to begin with, no amount of observability is going to help you, because you're not actually going to be able to take those insights from looking at your code and figure out, how do I take action? How do I fix it? Right? It doesn't matter if the time to query and understand, if it takes 10 seconds to query and it takes 5 minutes to understand the issue, it's then stuck waiting 3 months for the next quarterly build. Right.
Right.
And also, it's really challenging to get started with observability if you can't actually enrich your code with those rich attributes, right? Sure, automatic instrumentation can kind of monkey patch and get you some visibility to start with, but ideally, the power of observability comes from enriching your data with business logic specific attributes. But again, like, if it takes 3 months to get those pushed to production so that you can then use them to run queries you didn't predict in advance, like, yeah.
Or if you've got DOPS or DevOps teams who aren't allowed to touch the code, right? And they're saying, do whatever you can without shipping any code whatsoever. That's too dangerous. We don't trust it. Like, you can only get so far treating your code as a black box, right? That's not observability. You can monitor, absolutely. You can say it's returning between these thresholds, it's good or it's bad, but you can't actually get any of the rich detail about what's going, like, it's not observability if it's not able to see inside the box and like explain to you back what's going on.
And I think where it really gets interesting is when you, as a developer, are able to start writing instrumentation along with new features with the idea that when you deploy to production, then you can see what is actually happening as soon as that starts getting real production traffic, right? And I think when we talk about the intersections, when it comes to DevOps, right, really what we're talking about is service owners, right? And if you are a developer that
service
is close,
ownerships and shipping faster and kind of small units of delivery, right? Like all those principles of DevOps, we feel are really supercharged by observability.
Yeah, and like, it's not just observability. Like, observability is kind of, I think, the prerequisite, as Liz was saying, but it's also feature flags. It's also putting software engineers on call for their own code. It's also chaos engineering. You know, I feel like there's been this big pendulum swing over the past 5 or so years away from, you know, we've gotten everything we can get out of like pre-processing our code before it goes into production. You know, we've reached really sharply diminishing returns because most of the really interesting things that happen are only going to happen in production. And so increasingly, all of the tools that you get a lot of bang for your buck out of are circling around, helping you understand, helping you slice and dice in production, giving you better visibility into production, giving you a finer progressive delivery is, I think, a huge thing. You know, it's all about getting to production more quickly and then being able to segment your traffic or tell what's going on, you know, or ship to certain users or not others. You know, there's a lot of different ways you can combine these things to bring you more reliability and predictability. But it starts with observability and it doesn't stop there. The other thing that I think is interesting is about cloud native, because, well, this is a buzzword that I don't use because I find it personally obnoxious. I also think that, you know, the shift from monitoring to observability is very, it's kind of a step function, and it often happens when people adopt the cloud because, you know, if you think about it, the more ephemeral your infrastructure, the more dynamic it is, the less those old patterns of predictability and black, white, up, down, the less those apply, right? And the more manual, you know, massaging they need, and the less it, you know, you really want some instrumentation that's just as elastic and just as dynamic as your infrastructure.
And if you think about it, monoliths, right? It's a transition from monoliths to microservices and from fixed servers to ephemeral servers, right? Like those are kind of, to decompose what the buzzword means, like that. And yeah. Again, like, you need to have observability because there's no longer like, you know, one place to go and grep through the logs. And it turns out to be horrendously expensive, and people pay these gigantic bills to send their data to a log aggregator, right? Like, it's like, no, there's a better way. There's a better way.
Everything's a high cardinality dimension these days. And the first high cardinality dimension that people usually run into is hostname, right? A lot of people will spin up, you know, their Prometheus or their Datadog, whatever, and they start thinking about tags to append. Hostname, that seems a really obvious thing to append, right? And then they get up to a couple hundred hosts and suddenly nothing works anymore.
Or when you have containers, right, that are like, you know, sure, you might have a couple hundred hosts, but you're actually running, you know, tens of thousands of containers. Oops.
Exactly.
And this is why people love to bill by the number of hosts or containers. It's like, no.
Yeah, exactly.
So, George, what do you think people should get from our book?
Well, you know, I mean, I think like I was saying earlier, you know, I hope there's a little something in there for everyone. I think, you know what, I will speak from my own experience. For somebody that was new to the world of observability, really trying to understand not just the technical differences, but the changes in behavior that are necessary to really wrap your mind around a new way of troubleshooting. I think, you know, we sort of cover that in parts as we go throughout the book. And then I think we build to a point where we even cover what that means from a culture and a team perspective, right? And some patterns for adoptions and ways to grow champions in an org to help you push your adoption along. I think that end-to-end journey of covering, you know, what it means from, you know, I guess, just the definition perspective, what it means from a technical perspective, and then what it means from like a cultural and adoption perspective, I hope is something that will, one, help disambiguate the term a bit, and two, give people something to really dig into and hopefully drive the conversation forward, right? So we're not just focused on pillars, but a better way of understanding and debugging systems, right? That's what I want to see people get.
Yeah. We talk about Honeycomb a fair bit in the book and here, but ultimately, like, if Honeycomb failed and observability succeeded, I would be happier than if Honeycomb succeeded and observability failed. And, there were lots of times in the first 5 years of the company where people were leaning on us so hard to do metrics and go where the money is, do these things. And we held fast, and we really thought we were going to fail there for a while. We haven't yet, thank goodness. But like, we all come from operations backgrounds, and we're all familiar with the pain, the agony, and the ecstasy of being on call, right? And of being that last, you're like the last best hope of survival. Like, everything's down, nobody's going to get it up but you, right? And like, we just have so much empathy for the people who are in this situation. And, as we all enter our 30s and 40s, we don't want to get woken up all the time. And like,
no one should have to suffer through that on call. No one.
No one should have to. It is not, like, I feel like people think it's a necessity, like it's a prerequisite for having a good software system. And it's actually the opposite. I think that, like, the rise and fall of happiness of developers and users tends to happen in tandem. You never see them diverge for too long, right? You don't have miserable developers and happy users, or vice versa. And like, the care and feeding of your engineering teams, this is where, I think we talk a little bit in the book about this, but like, making room in the product roadmap for actual, tech debt pay down and for reliability work, and making it so that it's not, it's clear that it's everyone's job to make sure that the business keeps running. It's not any one group of heroes and saviors, to like, man the barricades. That may be how we grew up, but it's not healthy and it's not sustainable. And, we see that more than ever now, because systems are so complex that, honestly, if you didn't have a hand in writing them or supporting them, you can't troubleshoot them, right? You have to get inside the code. You can't just fight the fire like it's, they're black boxes. And, I feel like the original sin of, like, the pre-DevOps sin was like, okay, engineers, you write the code. Okay, ops people, you run the code. And like, the entire DevOps movement was like born out of the fact that this was a lie. You can't actually build and run software systems this way, right? There can be specialties, but in the end, every single one of us needs to be writing code and supporting the code that we write. And
know how to debug the code, right? Regardless of how familiar we are with it.
You can't outsource that.
And
you cannot outsource understanding your
and it turns out, that it doesn't have to rely on your rockstar engineers, right? You don't have to rely on the senior most person to answer every question. There can be a repeatable method and a way of understanding and combing through that data to objectively figure out where is the problem. And that, I feel like, you referenced the original sin of DevOps, and somewhere in there, we just came to the conclusion that, there's no possible way to understand what is happening with this code. And I think it's time that we resolve that lie,
Absolutely. And the thing is, like, we've seen this happen now. We've seen this happen on our teams. We've seen this happen. It used to be, like George has said a couple of times, that, pretty much the debugger of last resort was always the person who'd been there the longest, right? That was me. That was my niche, right? And it's a good feeling, but it's a better feeling when the best debuggers are the people who are the most curious, and the people who, look at their code after it's been shipped every time. Because if you weren't looking at your code after you've shipped it every time, you don't actually know what normal is, right? You only know what normal looks like if you see it every day. And part of our mission at Honeycomb, I think, has always been inviting people into production and trying to make it friendly and trying to make it so that it's not this scary, walled off thing that only the experts dare tread, right? Everyone needs to, if you're writing code, you need to understand your code.
But we haven't offered you the tools to do this before that, right? Like, it was, you have to be, a charity or a Liz or like some kind of systems engineering wizard to operate systems. And it's like, no, we can make it so that it's not intimidating to operate your own code. Every engineer should be able to do it and supported in doing it. This is not like, we're subjecting you to a bunch of pain and masochism.
What I really like about doing this book in tandem with O'Reilly is that, we've really had to be very objective and instructive around how to build a solution like this as well, right? If you want to go down the path of really doing this, here's what you need to know about what the outcomes are, how it needs to operate, how it needs to come together, what the functional types of questions are that you need to answer, right? And like Liz said, right, the rest of it is let's show our work, right? Here's an actual example of this. And so hopefully, right, anybody can pick up this book and start wading their way through like what it means to build, what it means to operate this way, and what observability really actually is.
And I think the really other really cool thing, as you mentioned, George, is like working with O'Reilly. It's been great being part of the broader ecosystem of similar books by O'Reilly that have been published by O'Reilly. Like, I know that for one, I was very, very inspired by the original kind of SRE books, Site Reliability Engineering, the Site Reliability Workbook, and Seeking SRE as these kind of resources that really define what does it mean to be an SRE? And we're hoping to do the same thing for observability.
The SLO book was great. Another one that's coming out, not O'Reilly book, but...
Oh, yeah, the SLO book is separate from the SRE book.
Yes, the SLO book
there is a SLO book.
The SLO book is another book by Alex. That's a really great book. It's very practical. It's very friendly. It's very inviting. And then another Alex Boughton from Lightstep is writing a book on OpenTelemetry that will be out about the same time as ours, I think.
Yeah, and there also was a book already published, again, by some of the folks at Lightstep on distributed tracing in general. So kind of lots of really fascinating books in the space, spanning all the way from, cloud native applications in Kubernetes to SRE to OpenTelemetry, right? Like, I think that kind of helps put together this picture because there are so many things we wanted to include in our book, but we couldn't. And it turns out other people have done it. It's great.
All right. This has been super fun. Any last words?
I think the only thing I'd add is if you're listening to this, if you're a O'Reilly Safari subscriber, you can get access to the book raw and edited. Well, less unedited now. It's had several passes, but you can have access to kind of our work in progress on O'Reilly Safari. And if you're not an O'Reilly Safari subscriber, Honeycomb is providing complimentary access to the to early release of the book. So we'll drop a link to that in the show notes.
Yeah, there's a honeycomb.io/blog is where we drop a lot of posts on this stuff, and the Honeycomb.io Twitter account. And you can find me at Nipsey Tipsy on Twitter. Liz, where can they find you?
You can find me at Liz the Gray, except for it's with a E, not an A, and it confuses people sometimes.
That's how gray should always be spelled. I'm with Emily of New Moon on that one.
I'm definitely with you on that. And you can find me at gmiranda23 on Twitter. And like Charity said, we're dotting the I's and crossing the T's on the final manuscript as we speak. So hopefully you should have the actual production print of this book very soon. And if not, you know where to find us before that.
Thanks so much for having us. This has been really fun.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.